Year 13 short revision video number 29. So, note the use of the phrase, in this question you must show detailed reasoning. Now, there are a lot of numbers, a lot of information in this question. We need to make sure we understand exactly what this question is asking us to do. Research showed that in May 2017, 62% of adults over 65 years of age in the UK used a certain online social media platform. Later in 2017, it was believed that this proportion had increased. In December 2017, a random sample of 59 adults over 65 years of age in the UK was collected. It was found that 46 out of the 59 adults used this online social media platform. So, what do we know? So, May 2017, we're saying that the proportion is 62% of people, which could also be written as a probability, 0.62. Now, later, it was believed that this proportion had increased. We then find that we've got a random sample of 59 adults and 46 of them were found to use the platform. Now, this is a binomial distribution. We're counting. X, define what we are counting. X is the number of adults over 65 using the platform. So as soon as you see a discrete calculation here, the fact that we are counting the number of adults, it becomes very clear that we're going to have to model this using the binomial distribution. So X is a binomial distribution where N is 59 and P, we're assuming originally, is 0.62. Now, we've got to set up our binomial distribution hypothesis test. So H0 is, of course, the status quo, which was May 2017. It was believed that the proportion of people was 62% or probability of 0.62. Now, it's believed that this proportion has increased, and we are testing whether there's evidence of an increase between May and December. So this is a one-tailed test where we're testing our alternative hypothesis, P is greater than 0.62. We must define what P is. Okay, we've introduced this letter P. We've got to be clear about what it is. P is the... Now, you can define this in different ways. I'm going to say P is the probability an adult selected at random from the population uses the platform. Now, I probably should say an adult over 65 selected at random from the population uses the platform. Now, we are going to need to do a probability calculation based on our test statistic. So 46 out of the 59 adults used this platform. So we're going to work out the probability that X is greater than or equal to 46. So we look at our scenario and then scenarios that are more extreme cases, i.e. 46 or above. Now, let's do the calculation. So on our graphical calculators, I would always do this in statistics mode. And you need F5, which is distribution. You then want binomial, which is again F5. And we then want binomial cumulative distribution, which is F2. Now from there, for your settings, you want the data to be variable. The lower value is 46. The upper value is, of course, 59, which is the maximum number of people in the trial. Number of trials is 59, that's N, and P is taken as 0.62, the original probability. Now, this gives me a value of 0.006811, and I'm going to convert that to a percentage. It's 0.6811%. Now, we must then compare that to the significance level, and it's clear that this is less than 1%. So the result is significant at the 1% level. That means we have sufficient evidence to reject H naught. And we have sufficient evidence to suggest an increase in the proportion of adults over 65 using the platform. Now, notice the way I have framed my conclusion here really carefully. We have sufficient evidence to reject H0. I haven't referenced H1 at all, and we shouldn't ever reference our alternative hypothesis. I also haven't said we've proven or we've clarified that there has been an increase in the proportion. I've used grey terminology here. It's a non-assertive conclusion. So we have evidence to suggest, or sufficient evidence to suggest, there's been an increase in the proportion of adults. And notice I've gone right back to the terminology of the question and put my answer in the same context. I've used the wording in the question. The question is referred to testing for evidence of the proportion of adults increasing, so I have used that same wording in my conclusion. Now, we could do this whole problem using, for example, a critical regions method. The simplest method is this way, so using a probability calculation. Unless we're asked to find a critical region, there isn't value in actually creating extra work for ourselves. Use the simplest possible approach.